Your skin is not decoration. It's a receipt, written by the sun, for a place your ancestors once stood. 2 million years ago, on the open grasslands of East Africa, your earliest ancestors were losing their body hair. Bare skin meant sweat could cool the body fast, letting them hunt through the hottest hours, when other predators had to rest in the shade. But bare skin under an equatorial sun created a new danger, one hiding deep inside the blood. Most people assume dark skin exists only to stop sunburn. That is not the deepest part of the story. The real driver was folate, a vitamin the body needs to build DNA and to shape a developing spine and brain. Ultraviolet light destroys folate in the bloodstream, and a mother without enough of it risks devastating harm to her unborn child. Skin that produced more melanin protected that folate, protecting the next generation before it was even born. Anthropologist Nina Jablonski, working with geographer George Chaplin at Penn State, mapped UV radiation levels across the globe against the skin tones of people native to each region. The pattern was almost too clean to be coincidence. Near the equator, where UV burns strongest, skin was darkest. Toward the poles, it grew lighter in a near-perfect gradient. But if dark skin was protective, why did any human population evolve to be pale at all? Because protection carried a hidden cost. Skin uses UVB light to build vitamin D, which strengthens bones and supports the immune system. Around 70,000 years ago, as early humans walked out of Africa into dimmer northern latitudes, their equatorial skin began blocking too much of the very light it now needed. Picture a band of early modern humans camped at the edge of a pine forest, under a gray, low-hanging sky, nothing like the blazing light their ancestors had known. A child is born with skin a shade lighter than her mother's. It seems like nothing, but her bones grow denser, and she survives a brutal winter that a darker-skinned relative, quietly weakened by vitamin D deficiency, does not. Multiply that single advantage across hundreds of generations, and entire populations were reshaped by nothing more than where the sun sat in the sky. Here is the twist almost nobody expects. Light skin did not evolve just once. Researcher Keith Chung, also at Penn State, traced one key gene, SLC24A5, through a 2005 zebrafish study published in the journal Science. That variant is common in Europeans. East Asian populations evolved lighter skin through largely different genetic pathways, two separate groups solving the same problem of weak sunlight in different biological ways. In 2018, researchers at London's Natural History Museum analyzed the DNA of a 9,000-year-old skeleton found in Somerset, known as Cheddar Man. The pigmentation markers suggested dark brown to black skin, alongside blue eyes, a man in what is now Britain still carrying skin built for equatorial sun, long after the Ice Age had ended. Pale skin may not have become common across much of Europe until roughly 6,000 to 8,000 years ago, a blink of an eye in evolutionary time. Every population on Earth descends from the same African ancestors. Skin color reveals almost nothing about lineage, only how much direct sun recent generations lived beneath, and for how long. Now most people spend their days indoors, behind glass that filters out the UVB light their skin once depended on, while reaching for sunscreen, chemistry doing in seconds what melanin took 100,000 years to build. Your skin was never decoration. It has always been a record, written not by who you are, but by where the light once found your ancestors.